In this video, we're going to look at examples of solving by square roots. So, if a quadratic, so we have an x squared, has no x's that aren't squared, you can solve by square roots. So let's look at examples of what this means. Which of the following can be solved by square roots? In this first equation, the only x in the problem is an x squared. That means this problem can be solved by square roots. The one underneath that, this x is squared. It has a +2 with it also, but it's still x squared. That means this can be solved by square roots. In this problem, we have an x squared, but we also have a term with an x in it. This problem cannot be solved by square roots. This one has an x squared, but it also has an x in it. That cannot be solved by square roots. We can still solve these things by factoring or quadratic formula, just not square roots. This problem has an x squared in it. There's no other x's, so this can be solved by square roots. This problem has an x squared in it, but it also has an x that isn't squared, so it cannot be solved by square roots. One of the important things about solving quadratics is realizing which method will work. The only way we can solve using square roots is if we only have squareds. We don't have any x's that aren't squared. All right, so let's look at an example of actually solving a square root problem. In example 1, we have 4x squared minus 25 equals 0. First of all, we had to be sure the only x in the whole problem was an x squared. There weren't any x's that weren't squared. Also, to solve a quadratic by square roots, the first thing we're going to do is to isolate the x squared. That means get x squared by itself. In order to get x squared by itself in this problem, I need to move the 25 to the other side of the equal. How do I do that? I do that by adding 25 to both sides of my equation. So now my equation is 4x squared equals 25. The x squared still isn't by itself because it's times 4. To get rid of times 4, the opposite would be to divide both sides of the equation by 4. Now I have x squared equals 25 over 4. I like to leave things as fractions. I don't want to change them into a decimal. So once the squared is alone, now I'm going to square root both sides. Don't forget that when you take the square root of both sides, you always need a plus or minus. So I'm going to square root here, and I'm going to square root here, and I also need a plus or minus. Why do I need a plus or minus? Well, let's go over here for a second. If I had x squared were equal to 4, then x could equal 2, or x could equal -2, because in both cases, if I squared, I would wind up with a positive 4. So whenever I take the square root of both sides, I need to put a plus or minus in there. I also could see this if I rearranged this equation, x squared equals 4, and I change that to x squared minus 4 equals 0. I could factor that into x plus 2, x minus 2, because it's a difference of squares. We can see, if I do that, that my two solutions are going to be x equals 2 and x equals -2. Now they go to the other answers, but that doesn't really matter. We've got two answers when I have a quadratic, one plus, one minus if I'm square rooting. So now that I've got this square root, I can't leave a square root that looks like that, so I need to simplify whatever the expression I have is. Remember, if I have a fraction, try to see first, could I just reduce the fraction? Does 4 go into 25? No, it doesn't. But what's the square root of 4? The square root of 4 is 2. And what's the square root of 25? The square root of 25 is 5. So I wind up with two answers, plus or minus 5/2. Let's look at example number 2. In example number 2, I know I can use the square root method because I only have a single x in the whole problem and it's squared. So first thing I need to do is get the x squared by itself. To do that, I'll divide both sides by 3. Since 3 goes into 24 nicely, I have x squared equals 8. The next step is to square root both sides. Remember, when I square root both sides, I need a plus or minus. The square root of x squared is x, and then over here on the right, I have plus or minus the square root of 8. My final step is to simplify. If I simplify the square root of 8, 8 is made up of 3 2's. So I have x equals the plus or minus. When I simplify the square root of 8, I can take a 2 out, but I still have a 2 left underneath. And there are my 2 answers. I can either write them as a plus or minus like this, or I could break it apart into 2 separate answers and call it minus 2 square root of 2 and positive 2 square root of 2. It doesn't matter which way you write it, but you should realize if it were multiple choice, you could see it either way. Okay, pause the video while you try example number 3. In example 3, I only had 1x squared, so I was good to go. I moved the 64 to the other side, which made it negative 64, and then I square rooted both sides. I put one plus or minus down, and then it was time to simplify the radical. So when I go to simplify this, I have plus or minus. The square root of 64 is 8, but I also had a negative underneath there, so I need to take that out and make it an I. The nice thing about the square root method is sometimes if you have an imaginary solution, that's okay. You'll get both answers using the square roots. So example number 4. In example number 4, I have a nice x squared because I have this whole little expression here squared, but that's not a problem. There's no other x's that aren't squared. So I need to isolate this expression. So to do that, I'm going to get rid of the 32. To move the 32 to the other side, I subtract 32 to move it over. Now I need to get rid of the squared. To get rid of the squared, I do plus or minus the square root. Then I need to get the x by itself, so I'm going to add 3 to move that over. When I add 3 to both sides, it doesn't matter if I write 3 plus or minus the square root of negative 32, or if I write plus or minus the square root of negative 32 plus 3. I'm going to write my answer in this form because that's the way it'll usually turn out in multiple choice, with the whole number part first. Last, I need to simplify my radical. So 32 was 4 times 8, so I can break 32 down into a whole bunch of 2's. I can take 2 2's out, so I have a 4 outside. I have to leave 1 2 in because it doesn't have a partner. I also had a negative underneath, so that's an I that I can take out. So there's my final answer, 3 plus or minus 4i square root of 2. Again, I can write it like this, or I can write 3 minus 4i square roots of 2 and 3 plus 4i square roots of 2. It really doesn't matter what order I write these two solutions in down here when I separate them, but typically the minus answer is going to be written first because it's smaller than the plus answer. Pause the video while you try example 4. So in example 4, I had x plus 2, which was squared, so I know I could use square roots. I added 27 to move that over to the other side. Then I divided both sides by 3 to move the 3 over to the other side. And now my squared was by itself. To get rid of the squared, I did plus or minus the square root of both sides. And then I had to get rid of the plus 2, so I moved it over by subtracting 2. So now I have x equals negative 2 plus or minus the square root of 9. Now I need to simplify my square root. The square root of 9 was 3. So now I have negative 2 plus or minus 3. This could be broken into 2 parts. The negative 2 minus 3 would give me negative 5, and the negative 2 plus 3 would give me positive 1. Since I can put these things together, I should, and I have my 2 answers, which I can also write in a solution set of x equals negative 5 and 1. turn the page over and try the examples on the back. For each example, like here's problem number 1, over in the right column, we're going to have another method to solve number 1. So according to the directions, we need to solve number 1 by square roots, give an answer in simple radicals form. Then, if I look at the problem corresponding to it, it says solve number 1 by factoring. Did you get the same answers? We know we should be getting the same answers. If we're not, there's something wrong. So then you can go back and check these other problems on the left. So this will correspond a problem on the left with a problem on the right. And pause the video while you work these, and then check your answers when you're finished. For problem number 1, I got plus or minus 1/6 when I solved by square roots. If I looked at number 7, I got x equals negative 1/6 and x equals positive 1/6 by factoring. If you didn't get this right, pause the video while you figure out what you did wrong. In number 2, I solved by square roots. I got plus or minus 7. In number 8, I had to solve the same problem by factoring. I also got plus or minus 7. If you didn't, pause the video while you figure out what went wrong. For number 3, I solved by square roots, and I get plus or minus 2i square root of 3. Number 9 said plug your answers to number 3 back into the original equation. Do you have a true statement? So I took this answer that I got in number 3, and I plugged it back in for x in the original problem. I can do this right on my calculator. I can type in exactly like I have written here and hit enter, and my calculator should equal 0 because that's what I had on the right side of the equation. If I then went through and plugged in the minus version of the same answer and hit enter, my calculator should give me 0. If it's a true statement, I know that I've found a solution for the equation. In number 4, I solved by square roots, and I got 3 plus or minus 4i. Number 10 says sketch a quick graph of number 5. Oops, I'm jumping down here. So let's look at number 5. Number 5 also had two imaginaries. It was plus or minus 2i square root of 10 over 5. So for both 4 and 5, if I were to sketch graphs of those problems, I would realize that my graphs have no x-intercepts. If my graph has no x-intercept, that's a good sign. I should have imaginary answers. So I could do a quick check that way. Pause the video if you need to look at the answers to 4 and 5. For number 6, when I solved by square roots, I got plus or minus the square root of 15 over 3. Number 11 asked me to solve number 6 by graphing and estimating the x-intercepts. So if I graph this on my calculator, or even if I graph it by hand, I can see that I cross the x-axis at 2 places, right here and right here. That's a little bit more than 1 and a little bit more negative than negative 1. If I type the answer that I got solving algebraically and make it a decimal, it should match with these two numbers. If not, pause the video while you try to figure out where your mistake was. Come into class tomorrow with any questions you have left on these.